Hello dear students. So in the last video lecture we studied about general method of preparation for carboxylic acids and acidic nature of carboxylic acid. Okay, in this video lecture we will see some chemical reactions involved with carboxylic acid, that means chemical behavior. The first one is formation of anhydride. Just in the last video we have seen that when anhydrides are hydrolyzed they produce acid. Okay, but it will be just the reverse reaction. That means if you just take out this water, how to take out this water? You just use a concentrated sulfuric acid and you will get anhydride. Just removing this water will give you anhydride. Okay. Now the famous reaction that just we discussed in the last class, esterification. The reverse was being taught as general method of preparation. So esterification. So how esterification? We will directly see the mechanism, okay, because we know the product, we have already seen this reaction too many times. So not going to the reaction, I will go to the mechanism part. So this is our acid, okay. So in the first step it will get protonated. We will protonate it, I guess, yeah. So we will protonate here. So it will become positive. Now this alcohol has two lone pairs. This alcohol has two lone pairs on oxygen and this carbon is positively charged. Okay. Okay, what will happen? This bonded electron will move to the oxygen, okay, and this proton, it will become a proton. This proton will be transferred here. Okay, something like this. So this oxygen has two lone pairs now. In the next step, this water molecule will move out. Okay. So hydrogen will, it has a positive charge right now. Okay. So this hydrogen will give its lone pair here with its bonded pair here. And we get this. We lose one proton. So we used the proton that we used is being liberated here. Okay. Okay, that's the overall mechanism. Okay. This lone pair in this stiff ships here, so we get here. So we lose the proton will donate its electron here. Okay. So this is the overall mechanism of esterification reaction. Okay, this is the mechanism of esterification reaction. You already know the reaction, that's why I didn't go for the reaction actually. The reaction was something like that. The reaction was like this, and we use H plus. What we get this. Okay, so this is the reaction, and you know, that's the mechanism. So instead of going for the reaction, I discussed the mechanism. You will find the mechanism in NCERT book also. Okay, or you can, you know, you can just rewind this video few times and see for yourself. Now third is, next one is reaction with PCl5, PCl3 and SOCl2. That means phosphorus pentachloride, trichloride and thionyl chloride. Okay, this reaction is very much similar to the reaction that we have seen in alcohol. It will react with this part only, okay, OH part. So we have seen that in alcohol, when we treated alcohol with PCl5, we got Cl replaced the hydroxyl group. The same thing will happen here also. It will replace the OH group and we will get PuCl3 plus HCl. Okay. Next, if we take PCl3, same reaction as alcohol, just a bit different. But quite similar to the reaction that we have discussed in alcohol. Okay. And finally, if we take SOCl2, it remains the same. We get SO2 and HCl. We get SO2 and HCl with thionyl chloride. So this is a gas. Okay, it's in the gaseous state. So this is the reaction. Okay, now reaction with reaction with ammonia. That means NH3. So when we treat carboxylic acid with ammonia, it gives ammonium carboxylate first. Okay. Oh no. Yeah. The O negative will remain. Okay. That means RCOO negative and NH4 positive. The whole thing, the whole RCOO OO negative will remain as anion and NH4 will remain as cation, ammonium cation. So ammonium carboxylate, and heating this ammonium carbonate will finally give you amide. Heating this ammonium carboxylate gives finally an amide. Okay, you can see different reactions. Okay, so for some time I'll keep there. Then let's see an example. I'll try one example. COH, ammonia, H4, negative positive, strong heating, and what we get? We get CONH2, sorry, CONH2, benzamide. We get benzamide. Okay, this is benzamide. Okay, now we will try to synthesize one very important chemical, which is very essential, very useful reagent. Okay, we will need that reagent in our next chapter. It's very useful because it is used in the preparation of primary amines. So we will see that how that thing is prepared. So it falls in the reaction with ammonia only. So we will use dibenzoic acid. When treated with ammonia, it will first form this. On heating, it will form this. Now this is called phthalimide. And this phthalimide is, if strongly heated, okay, it will produce something like this. And this is called phthalimide. Okay, P is silent. Phthalimide. Now this phthalimide is a very important chemical. Okay, in amine we will see that for the preparation of amines we need this phthalimide, and the reaction is called benzene phthalimide reaction. Okay, so this is a strong this chemical is very useful in preparation of different chemicals. Okay, so that's why we separately studied the preparation of phthalimide. Now we'll see next reaction after the preparation. This phthalimide, okay, we'll see, no, not Gabriel phthalimide synthesis, because Gabriel phthalimide synthesis will be in the next chapter. For now we'll see reduction. Okay, reduction, very easy. Just in the previous video lecture we have seen that in general method of acid we have seen that oxidizing alcohol produces acid. So reducing acid, in general method what we have seen that if you oxidize this, you get this. So what will happen if you reduce this? Obviously you will get this only. So if you reduce it, this carboxylic acid, lithium aluminum hydride, then you will get CH2OH. Instead of lithium aluminum hydride, you can use diborane, and it will give you the same product. Okay, so instead of lithium aluminum hydride, you can use diborane. Okay, so its first step and second step is acid hydrolysis. So acid hydrolysis is required just to purify. Okay, now see, this reaction is not that difficult. Now see, the important part in this reaction is we have taken LiAlH4 and B2H6, but keep in mind that NaBH4, it is a very good reducing agent. We have used this chemical over time as a reducing agent, but NaBH4 is not used to reduce carboxylic acid, okay, because it cannot reduce carboxylic acid. Okay, it has not that ability. Okay, so it will not be used. And then after reduction we have decarboxylation. Okay, decarboxylation. Actually this decarboxylation reaction is actually again from class 11. Okay, is from class 11. So sodium salt of carboxylic acid, you can prepare this by reacting this carboxylic acid with sodium hydroxide. When treated with soda lime, this is soda lime. Okay, when they are combined together, soda lime, so it gives RH, that means alkane, and CO2. NO2CO3, yeah, sodium carbonate. Okay, and this reaction is something like, suppose if we have CH3, COONA, and if you use soda lime, then you will get, this is CH3, that means you get CH4. You see, this reaction has an importance. Why? If you start with ethanoic acid, you get methane. That means the product has one carbon less. So to go down in a homogeneous series, we have a homogeneous series which is separated by CH2. That means to reduce the number of carbon in a chain, while we do conversions, so to go down in the chain you can use this reaction to cut out a single carbon. Okay, well, it will cut a single carbon. It will give you it will take you one step lower in homogeneous series. Okay. Now the decarboxylation, they actually in our NCERT class 12 book they have discussed only this reaction, but there is also there is one more reaction actually which was there in class 11. It's called Kolb's electrolysis. It's not there in your class 12 book. Even in NCERT they have written that you have already studied in class 11. So it's not just me who says this, it's NCERT also. So what happens in Kolb's electrolysis? Same sodium salt of the carboxylic acid. If you do the electrolysis, you will get this. This time you will get this, and CO2 will be bubbled at anode. So the main thing is that you will get, this product, okay, in electrolysis. RR, that means if you start with ethanoic acid, and electrolysis, then this will be the product. Okay, just repeat it twice. Okay, so this will be your final product. Okay, this is Kolb's electrolysis, and it's a free radical mechanism. It has a free radical mechanism. If you can spare some time, then go for this reaction from class 11, see the mechanism. Okay, if you find any difficulty, any confusion, then you can tell me. Okay, you can ask your doubts regarding this question, but I hope you will be able to solve questions if something comes from Kolb's electrolysis. Okay, now our next reaction is, it's a named reaction. It's called actually I always remember the short name, so let me write it down. Helmholtz-Jelsinki. Helmholtz-Jelinski. In short, it's called HVZ reaction. Okay, HVZ reaction, that means Helmholtz-Jelinski reaction. Okay, just rewind and go back to 5 or 10 minutes. Just rewind 5 or 10 minutes. You will see that I have I did a reaction with PCl5, PCl3 and SOCl2, and what happened, the chlorine was replaced by this OH, but now I want to substitute a chlorine or halogen, but not here. I want to substitute here. I don't want to substitute this OH group. I want to substitute this hydrogen. Then what we will do? X2 in presence of red phosphorus. Okay, in first step, and then hydrolysis. And it will do what? It will replace halogen from the main carbon chain. Okay, it will replace hydrogen from the main carbon chain, and you can see that this X can be chlorine and bromine. So it will replace from the main carbon chain. Okay, So that's called Helvollard-Zelinsky reaction, HV-Z reaction. Now the final part of carboxylic acid is here, that is electrophilic substitution. Very easy. COOH is meta-directing as well as deactivating. It does not undergo Friedel-Crafts reaction. Friedel-Crafts reaction it will not see, because it is deactivating, but it will show nitration and bromination. So HNO3, H2SO4. So what we will get? We will get nitro group at meta position because it is meta directive. Okay, and if we go for bromination, then we will get bromine at the meta position. Okay, because it is meta directing and deactivating, so no Friedel-Crafts reaction, only nitration and bromine. Okay, so guys, we have finished our final topic from carboxylic acid. So this is all that we have from carboxylic acid. In the next video lecture, we will discuss some problems from exercise questions, as well as we will see some questions from previous year question papers. Okay, you too go through these video lectures carefully. Okay, the assignments will soon be followed by this video, after this video. So once the lectures are finished, will be given assignments, so do those assignments on time. And if you are not able to solve those assignments, actually assignments are given to you so that you can practice. So if you cannot solve any assignment, after the submission date is over, you can get back to me and you can ask that which question you couldn't do. Okay, then I'll help you to solve those problems so that you can practice those questions. Okay, so in the next video lecture we will do problem, and after that you will get assignment and new video lectures from any other chapters. Okay, this is all. Thank you.